Okay, welcome back to this next video tutorial. What we've done so far is look at the sine, cos and tan trig ratios. What we'll do today is have a look at how do we work out what ratio we're using. Now we know that sine is obviously opposite over hypotenuse. The cos ratio is adjacent over hypotenuse, and the tan is opposite over adjacent. Sometimes it can be really tricky just to memorize those things, but there is a way that we can really easily recall all of those sine, cos and tan ratios. And what we use is this little mnemonic. It's called SOH CAH TOA. Let's have a look how it works. Now what I'll do is I'll write the sine and the cos and the tan all together, and we'll see how is this SOH CAH TOA going to help us. Okay, if we can remember SOH CAH TOA, when we label the triangle that we're faced with, the triangle where we're trying to solve an unknown length, what we can do is have a look at what we're given. Now we're going to be given one side and we'll be working out another side. So really we're working with two sides at a time. If those two sides are O and H, what we can do is go, oh, O and H, that's so. That must mean it's the sine ratio. So then we write the sine ratio. So S for the so, we can highlight that there. And because it's written in the order O over H, we can remember it that way. We will always remember to write the sine rule like this. We don't need to look at our summary book. We don't need to refer to the rule. It should be memorized. It should be in our heads. Secondly, if you've got A and H, the combination of the two sides you're working with is A and H, and you can remember CAH here, you would then realize straight away, I've got A and H, that's CAH, C for cos. So we can see here again, if I highlight the C, that links with A over H. So if we can remember CAH, that's what we're remembering. Cos theta is the adjacent over the hypotenuse. And obviously tan, if we do the same thing, T for tan, T for TOA, O over A. SOH CAH TOA. In a test, you might like to write that at the top of the page, for example, just to help you out. But this is what we're working with here. Pause here and put this into your summary book. Okay, what we'll do is we'll look at some examples. Now, the trig ratios that we've done so far, I've told you what ratio we're using, but ideally, we need to be able to work that out ourselves, don't we? You're going to be faced with a particular question like this here, and it may not say to you, use the sine ratio, use the cos ratio, use the tan ratio. You've got to work that out yourself. The first step always is to label. So here we've got the adjacent side. Now it's already labelled with an A there, so I'm going to leave it there instead of putting another A. What have I got here? Well, obviously that one there is the hypotenuse. This is the opposite side, so I'll put that there. I'm working with here O and A. Now if you have your sine, I should say, let's undo that. I was getting a little bit carried away. Jumping a step ahead. So, CAH and TOA, SOH CAH TOA. If we can remember that. Here I've got O and A, that's OA, TOA. This bit here, T for tan. I know I'm using my tangent ratio. So that's my first step. Second step, we're going to solve just like we have done previously. 15 is the opposite side, A is the adjacent side. And now, finally, tan 30 times by A equals 15. Therefore, A is equal to 15 over tan 30. Pop that into your calculator. And what we can do is we'll round off to 2 decimal places, I think would be good. So 15 over 10, 30, I've got 25.98. put it into your calculator too. Make sure you are getting the same answer. If you are not, make sure you are in degree mode, as always. Let's have a look up here. Was there a unit? Yes, centimetres. Here we go. One thing I always like to do as well is I look at my answer. Here I've got 25.98, and what I do is I go up to the top and I think, well, does that make sense with this triangle? If that side's 15, could that one be 25.98? And yeah, it seems reasonable. If, say, for example, you're finding the hypotenuse and you get an answer that's smaller than this other side that you've got, you know that you've made a mistake because, of course, the hypotenuse must be the longest side. Also, if you get a negative answer, you know that you've got a problem in your workings as well, or your calculator may not be in degree mode, so please check that. So that's what we do when we're faced with one that we don't know what ratio we're using. Use this SOH CAH TOA to help you work out what you're doing, to help you to memorize those. Pause about here to get the diagram, and then I'll zoom down so that you can see all of the workings. You can pause there and you can put that into your book if you wish. We do already have some examples for this, so it's not absolutely necessary to get these ones into your book. All right, here we go. Let's try another one. We're going to label first. O and H. Have a look at your SOH CAH TOA. It's the sine rule. You might like to pause here and have a go at this before I do it. How are you going so far? Hopefully you're following. Sine 44, we're multiplying by 11.5 so that we get y as the subject. And I've got 7.99 to 2 decimal places. Have a look at the unit, centimetres. Yep, there we go, 7.99. I'll do a couple more. Here we go, just a couple more examples. First step, always, we label. This x looks like the hypotenuse, and there we've got next to the adjacent side, oh, I just gave it away, next to the reference angle and the right angle, adjacent side. So remember, I've done it, SOH CAH TOA. A and H, there it is there, it's my cos. Cosine ratio is A over H. Cos 21, so this is where I'm substituting, 2.7 over x. And this is one of the ones where we have to do it in a couple of steps. Double check, 2.7, yep. Now I will type that into the calculator, and again, always check how many decimal places you've been asked to round to. In all of these examples, I go to 2 decimal places. And I've got here 2.89. Is there a unit yet? There, yes, metres. So I'll put that in. And also, check that my answer makes sense. If that's 2.7, could this be 2.89? Yes, it could be, because it's the hypotenuse. It will be a little bit longer than that one there. There we go. If you would like to put this into your books, remember you just need to pause. The final one now, let's have a look. Don't have the hypotenuse here, but I do have the opposite side, opposite the reference angle. This one here is the adjacent. O and A, TOA, that means I'm working with tan. Substitute. your values in. And again, this looks like one where I have to do the double step. And then x would be equal to 17 over tan 32. Okay, type that in, and 2 decimal places, we get 27.21. Unit, centimetres. So let's have a look. Yep, that could make sense. 17 on that side. Remember, these aren't drawn to scale. 27.21 on the adjacent side. Again, if you want to, you can put this into your book, but like I said, we have already done examples like this. So really, this is just showing you how I get from the SOH CAH TOA, how I get from this diagram to recognizing which of the ratios am I using, and then therefore I can solve it from there. Okay? So again, pause it if you wish, but otherwise, thank you for listening.